It's called a supernova.
A supernova is the greatest cataclysm in the history of the entire universe.
Supernovas come in different sizes and types. All of them are so bright, they can be seen across the universe.
A supernova is the most violent death of a star you can imagine.
But this violent destruction of a star is also the birth of everything we see around us. Really big stars die with a violent explosion called a supernova.
A supernova can outshine an entire galaxy, releasing trillions of times the energy of our sun.
They're so violent, if one of them exploded just a few dozen light years away, planet Earth would be scorched.
A nearby supernova would really ruin our day. First of all, the sudden burst of radiation would scorch the atmosphere. The only place to go is underground. Underground, you could then withstand the blistering burst of X-rays which hit the Earth, and then it would scorch all plant life. And with the collapse of the food chain, we're talking about a possible extinction on the Earth.
Supernovas are destroyers. But they also create the basic elements that make up our world.
Our planet, our star, everything around us formed out of the debris of a dead, exploded star. Everything that makes up our bodies and the skyline came from supernovae. All of the iron, all of the silicon, all of the elements that went into these buildings. The things that make up my blood, my body, the gold in my wedding ring, everything you see here is a supernova.
But our sun won't become a supernova. It's too small. Like all stars, it's basically a giant nuclear reactor. The fusion reactor inside a star burns hydrogen, the simplest, most common element. The reaction fuses hydrogen atoms together, producing helium and energy. And when the hydrogen runs out, stars keep burning by fusing helium into carbon. Then carbon into oxygen. When small stars like our sun make carbon, they begin to die.
During the lifetime of a star, there's a balance between gravity pulling in and pressure pushing out. For a star that's generating energy, there's no problem. But once energy generation switches off, the pressure goes away and gravity wins.
Gravity now begins to crush the center of the star. The star's outer layers are pushed outwards. They expand into a huge ball of gas called a red giant.
Our sun, when it dies 4.5 to 5 billion years from now, its corona will go all the way out to Mars. Everything on the planet Earth will vaporize.
While the outer layers expand, in the center of the sun, gravity will have the opposite effect. It'll crush the sun's core to just a millionth of its original size, to about the size of the Earth. Now it's a dense ball of oxygen and carbon called a white dwarf. In our solar system, this will be the end of the story. The gas from the dying star will gradually disperse, but the tiny white dwarf will burn for billions of years. But our solar system is unusual, as it has just one star. The fact is that the vast majority of stars orbit in pairs. When one of the two stars dies and becomes a white dwarf, if it's close enough, it starts stealing material from the other star.
Think of two stars rotating around each other. One star slowly sucking all the hydrogen and helium from its companion star. It's like a vampire.
As the white dwarf draws more and more fuel out of its companion star, it becomes heavier, more dense, and less stable. Inside, carbon and oxygen atoms are about to fuse together, and this is perilous.
A white dwarf, in some sense, is like a bomb waiting to be lit. There's a huge amount of energy stored in that star, gravitational energy and nuclear energy.
This white dwarf is turning into a Type 1a monster.
A Type 1a supernova is a 20 billion megaton thermonuclear carbon bomb.
It's one of the most explosive substances in the universe.
Eventually, the white dwarf drains so much material from its companion, it goes into nuclear overload. The carbon and oxygen inside it starts to turn into a common element, but one that's dangerous to stars.
You've probably seen in Star Trek the idea that there's some sort of secret technology that kills a star. Well, I mean, it's in your frying pan that you used this morning for breakfast. Iron.
The moment the white dwarf star starts to fuse carbon and oxygen into iron, it's doomed. Suddenly, the white dwarf explodes.
The nuclear explosion of a white dwarf include, among other things, huge amounts of iron. And in fact, Type 1a supernovae are vital importance to populating the universe with the kind of elements that are important to us.
Type 1a supernovas blast iron trillions of kilometers into space. And this is where most of the iron in the cosmos comes from. But what about all the elements that are heavier than iron? Gold and silver, for example. They also originate from stars. Single stars. Bigger stars. Supernovas make everything in the universe. Everything we see, all the material in planet Earth, was created inside a supernova. We're even made from dying stars.
Without supernovae, we wouldn't be here. Every atom in your body was once inside a star that exploded. And the atoms in your left hand may have come from a different star than the atoms in your right hand. You are literally stardust.
Almost all of the iron in our solar system came from a double-star supernova that exploded more than 5 billion years ago. From our planet's molten core to our skyscrapers, to the hemoglobin in our blood. It's all made of iron from Type 1a supernovas. But the heavier elements in our world, like gold, silver, and uranium, come from another type of supernova. A single-star supernova. This is our Sun. A single star has to weigh much more than our Sun for a supernova to form. And there are some monster stars out there. Some are dozens of times heavier than our Sun. And some are hundreds of times more massive. The heavier the star, the faster it burns. And when these massive stars begin to age and die, the nuclear reactions inside them speed up.
Giant stars burn through their nuclear fuel very, very fast. It's sort of the live fast, die young. The more mass a star has, the hotter it burns inside, the faster it burns through its fuel.
Unlike double-star supernovas, really massive single stars create lots of elements before they explode. Once they turn hydrogen into helium, helium into carbon, and carbon into oxygen, they don't collapse into white dwarf stars. Instead, giant stars keep on burning, building up layer after layer of new elements deep in their core.